Okay, let's make sure we're live. And we are. Well, I say we are, nothing's showing up. There we are. Okay. So, like I said, if you're a note-taking kind of person, you probably want to be taking some notes. I need to zoom way out. We're going to make a little chart here for you to keep this information that I'm about to give you straight. And like I said, it's a lot of information at first. But then we'll break it up and use it some, and it'll make more sense. Huh? You're probably going to want it, yeah. Because you're going to have to refer back to it. So if you don't have paper out for taking notes that you hang on to, this is not just paper you just take notes on and then throw in the floor on your way out the door. Or throw in the trash can. There's not really any point in doing that. So, but if you don't, you probably want to get that out, okay? So, what we're going to be talking about is some special segments in triangles. And the first one we're going to talk about is called a perpendicular bisector. Now, just based on those words, what do you think that's going to be? Perpendicular bisector. It's going to be cutting something in half at 90 degrees, right? So, think about a triangle with me. I'm going to sketch out a little triangle here. Think about a triangle, right? What could we cut in half at 90 degrees on a triangle? The what? What do you mean?
Go start at the top. Start at the top.
I think my coat needs a bath. I think my dog is laid on it. I smell it. Yeah. Okay, so if you're cutting something in half, at 90 degrees, that means you have to be cutting a segment, right? Where are segments at on a triangle? The sides. How many sides are there? 3. So how many perpendicular bisectors could you have? 3. Every side has a perpendicular bisector. Whether it's drawn or not, it's there. It's a segment that meets that side at 90 degrees and cuts that side in half. So I'm going to sort of sketch them. You do the best you can too. I'm going to eyeball about halfway across, right? That means that this side right here would be congruent to this side right here. And then I'm going to draw a segment that is roughly 90 degrees right there. There's my segment. That wasn't very good, but y'all get the idea. And then this side's going to have the same thing. So I'm going to eyeball about the center. That means this side is congruent to this side, right? And then I'm going to draw an angle that's roughly, or a segment that's roughly 90 degrees. And then we're going to have the same thing for this other side. And yes, I am turning my paper because it's easier for me to visualize like that. So, roughly here, about 90 degrees. So this side here is congruent to this side here. That's 90 degrees. I forgot my mark right there. So this is kind of what it looks like, right? Like that. Notice they all 3 met at one spot. Y'all see that? They all 3 met at that same place. That point where they all met is called the circumcenter. Okay? Now, based on what the triangle looks like, that might be inside the triangle. It might be outside the triangle. It might be on the triangle, just based on what the triangle looks like. But they all 3 meet at one point. And that point where they all 3 meet, that circumcenter, is equidistant. What does that mean? All the same distance from each vertex. That means if we drew a line from here, let me see if I got a different color. If I draw a line from here to here, and a line from here to here, and a line from here to here, all three of those lines would be the same. Same distance from each vertex. Y'all with me? Now, knowing this word is important because if I said to you, this is the circumcenter of this triangle, then that tells you that those segments are perpendicular bisectors, right? So I don't have to tell you they're perpendicular bisectors for you to be able to figure out that they are perpendicular bisectors. Y'all see what I'm saying? Okay. Now, we're going on to the next one. So the next special segment we're going to talk about is called angle bisector. Now, best guess, what do you think angle bisector is going to be? Say what? I don't care if the heat even comes on. If the air would just quit coming on, that would be awesome. Okay, what do y'all think an angle bisector is? Best guess? Starts at the vertex, okay. Okay, sorta, yeah. So it does start at a vertex. It has to do something very specific, which is has to cut the angle in half, right? So if we sketch out a little triangle, say like this little triangle right here, and we have a segment that goes through this angle, roughly like this, and that angle is congruent to that angle, that's an angle bisector. And then we got another one over here, and this angle is congruent to that angle, excuse me. And then we got another one over here. And this angle here is congruent to that angle there. So each one of those is cutting the angles in half. And notice, they all met at a single point again. And that point right there is called the end center. The end center is where the three angle bisectors meet. And it has some special stuff about it too. So the end center is equidistance from each side. So it cuts the angles in half, but it's the same distance from the sides. This one cuts the sides in half, but it's the same distance from each angle. Y'all see how that works? So the same distance from each side means if we go straight here, and that's 90 degrees, and we go straight here, and that's 90 degrees, and we go straight here, and that's 90 degrees, that this equals that. Same distance from all sides. Okay, we got two more. So here's our next one, median. Now you've heard the word median before. Where have you heard median or used median? What does it mean? Middle, right? Means that if you're talking about mean, median, and mode data analysis is what that is. When you're analyzing data. When you're analyzing data, median means the number that's in the middle, right? So how would we apply that concept to a triangle? What could we be in the middle of? Y'all got nothing?
The middle of the triangle?
Yeah. Just like the middle? Well, sort of. So on a median, the median is actually a segment. I'm just going to draw a repo triangle here. The median is actually a segment that's in the center of a side that goes from the center of the side, the middle of the side, across the shape to the other vertex. So it made this congruent to this. Now, how many of those could we have? Or how many of those does a triangle have? They got 3, right? 3 angles, 3 sides. So they're going to have 3 of these. It goes from the center of this side across the shape to that angle. So this side is congruent to this side. Y'all see what I'm saying? And then over here, same thing. Center of the side. So that this side here is congruent to this side here. Across the shape to the angle. And notice they meet in the middle. Y'all see that? And that point where they meet right there is called the centroid. Now, the centroid has a couple of cool facts about it. So, for one thing, the centroid is the very center of balance of that triangle. If we built this triangle and you drew these medians on here and cut it out, you could balance that sucker on your pen if you put it right there where they cross. The triangle would just balance. If you made it out of stiff enough paper, right? If you make it out of floppy paper, it's just going to flop around. But if you make it out of cardstock, you can just balance it right there on the end of your thing. Y'all see what I mean? Okay, so it is the center of balance. So that's an interesting thing, but it doesn't really help us when we're trying to calculate stuff most of the time. But the other thing is that each of these centroids are broke up into 2 pieces. Each of these medians by the centroid. And so the long end, the end that starts at the angle and goes to the centroid, that's 2/3 the total length. And the shorter end, the part that goes from the centroid to the side, is 1/3 the total length. So like if the whole length of the centroid is 9, then 1/3 of 9 is 3. 2/3 of 9 is 6. So 3 plus 6 adds together to get you the total length of 9, right? So it's 2/3 from vertex to centroid and 1/3 from side to centroid. And that's just how the ratio of the length of the median. All right, we got one more. And you've heard this word before also. Not attitude, but instead altitude. Now, what does altitude mean just in general? Height. It's the same thing here, basically. Okay, so we're talking about a triangle that is, hang on just a second. I'm trying to sketch one that'll give us something a little different. Okay, so we're talking about a triangle, right? Now, if I turn this paper around and I'm talking about the height of this triangle, that means I'm going from that point straight down. That's the altitude, right? And it has to be at a 90-degree angle to the other side. Here's the deal, though, Pickles. If you look at it like this, and I go from here, and I go straight down. Do y'all notice how if I go straight down, I'm not in my triangle anymore? And that's totally okay. We can draw this auxiliary line here and go straight down to the line that contains that side of the triangle. It doesn't have to be actually on that side of the triangle. It just has to be on the line that contains it, right? And then we're going to have the same thing going on for this one, right? So we're going to extend this line out. And then we'll go straight down here. So that that's our 90-degree angle there. Now, if I extend all of these altitudes out, and I did a fairly decent job drawing them, guess what? They all meet at a point too. So they all meet at this point that's called the Ortho Center. I'm trying to think of what's special about altitudes. I don't think there is anything. I think that's it. It just is what it is. Okay, so you got all this down? Because we're fixing to go apply this information, or at least the first two. So today we're just going to be talking about these two, but we're going to take this information and apply it to some problems. So we're going to have some triangles that we've got to find stuff about based on knowledge of perpendicular bisectors and angle bisectors. Okay? So hang on to that paper. All right, so skills practice 5-1. Look at this very first triangle and tell me what you notice. What do you see? Do you see what I see? What do you see? What do you notice? Tell me just one thing you notice.
90-degree angle.
We got a 90-degree angle. We got a 90-degree angle, and these two sides right here are congruent right here, right? So that actually tells us that this is a perpendicular bisector. Because if these two sides are congruent right here, that means that this is the same distance from this 90-degree angle. So if these are congruent, this is a perpendicular bisector, right? And if it's a perpendicular bisector, that means this side is congruent to this side. Which means we can set up a little equation where 5x minus 17 equals 3x plus 1. And if we can set up an equation, we can solve it. So what do we do to solve that equation? So we're going to subtract 3x from both sides, right? 2x minus 17. That's just a 1. So then we're going to add 17. That's a 1. I don't know what I was drawing to start with. So we've got 2x equals 18, right? Divide both sides by 2. And x is 9. Now, is that our answer?
No.
No, because they didn't ask for x. What did they ask for? FG. So if they ask for FG, then we got to plug 9 in there, right? So it's going to be 5 times 9 minus 17. Or, as somebody first period pointed, I think it was Elizabeth, we could plug it in this one and still get the same answer. And the math is easier on this one. So we would do 3 times 9 plus 1, which is going to give us what? 28. So what is FG? 28. And we don't have a unit of measurement. It's not angles. It's just a side length. So we just leave it at 28. Okay. All right. So look at this one here. On this one, they're asking for KL, which is this side length, right? They're telling us that this is congruent to this. The assumption that we're supposed to jump to here is that KR is congruent to KL. But they actually did not give us enough information here. Because these two being congruent does not make that a 90-degree angle. It doesn't make these two congruent either. Y'all see what I'm saying? So they actually are wanting us to jump to a little bit of a conclusion that that's 4.2. I think it's a typo. I think that this was supposed to have a mark and a mark on it to show us that those are congruent. And showing us those are congruent would tell us that that's congruent. Or if they had told us that this was congruent to this, that would have worked. Right? Okay. So, TU. Huh?
That's it.
Yes, that's it. TU. Now, notice here, they did give us that these are congruent and that these are 90 degrees. So by giving us that these are congruent and these are 90 degrees, what does that tell us about these two segments? That they're equal. So that's going to be 2x plus 24 equals 5x minus 30. So we're going to subtract 2x from both sides. right? Add 30 to both sides. So 3x equals 54. Divide by 3, and what is x?
Where did it come from?
Is that right? Is x 18? Okay, so once again, does this answer our question? What'd they ask? TU. So to find TU, what do we still have to do? Plug it in. So we're going to do 2 times 18 plus 24. What's that? 36 plus 24? Which is 60. So TU equals 60. And again, we don't have any unit of measurement on this. It's not an angle measurement, so it's not degrees. And they didn't tell us feet, inches, whatever. So it's just 60. Okay, look at this one. Notice how they're telling us that these are congruent. This is not a triangle, though. Do y'all see that? This is just an angle. And they're saying that this is the same distance as this. That means that this segment right here, that guy, is an angle bisector. Because that is the same distance from the two sides, meaning that these two angles are congruent to each other. So if this is 58 degrees, this one is also 58 degrees. So if they're asking us for LYF, what's our answer? 58. What if they had asked us for L or JYF? You just add them. 58 plus 58, or 58 times 2. There's 2 of them. Right. Okay, look at IU. So 19 and 19. What does that tell us about RU? It's an angle bisector. If it's an angle bisector, then that means that this segment and this segment are congruent. If these two segments are congruent, we can set up a little equation that says, oh, look, 2x plus 5 equals 7x. Then we can solve it. So we're going to do minus 2x. 5 equals 5x, right? Divide by 5. What is x? X is 1. Now, what was our question? What is IU? So what do we got to do? Plug it in. And what is it? 7. Do y'all see my ink drying? Can y'all see that when I write? I think that's the coolest looking thing. If you haven't noticed it, watch. Like when I write, it'll be shiny and then it goes unshiny. It's like you see it drying on the page. Okay, look at this one. So notice this is congruent to this, and these are at the same angle, right? That tells us that this right here is a angle bisector, which means this is congruent to this, which means 4x minus 1 equals 2x plus 5. Right? So, if we subtract 2x from both sides, that's going to give us 2x minus 1 equals 5. We add 1. 2x is 6. What is x? X is 3. Is that the answer? No, because they asked us for MYW. So that's this angle. So to find it, what are we going to do? What does it wind up being? 11 degrees. Because this is an angle measure, right? So it does get the degree symbol because it is an angle. So you got to put that angle symbol on there. Okay, we're nearly done, y'all. We're rocking right along. How are we doing on time? 9:21. We're doing good on time. We're going to have a little bit of free time today. Okay. So, maybe. It's according to how long these last two take us. All right, so look at this one. So they tell us in the directions that this is a circumcenter. Now, what did circumcenter go with? Which segment? Perpendicular bisector. So if that's a circumcenter, P. So this P, y'all, that P is that point right there. Okay? If that's the circumcenter, that means that each one of these is a perpendicular bisector. That means that this is cutting this side in half. Because perpendicular bisector cuts it in half at 90 degrees, right? That means that BR is congruent to RA. AS is congruent to SC. BT is congruent to TC. Now, there's actually one more set of segments that are congruent. Because if you go back and refer back to your chart, remember what we said about perpendicular bisector? About the circumcenter? They're equidistant from the vertex. So if we go to that circumcenter and we go to our vertex, you all right? Then we know this right here is congruent to this one. And that's congruent to that one. Because that has to be the same distance to all the vertices. Y'all see what I'm saying? Okay, so if we go to answer our question. Number 7 says, what is congruent to BR? Why will this not focus? So RA. So we would write segment RA, right? What about CS? What's congruent to CS? AS. So we put segment AS. What's congruent to BP? CP and AP. So we'd have to put both of those because it asks for every segment that's congruent. That make sense? Okay, now look at this last one. So it tells us that it's an in-center. Now what does in-center refer to? Angle bisector. So in-center is where angle bisectors meet. That means that they meet here, that means that this is congruent to this. And then this one is congruent to this one. And then this one is congruent to this one. Right? So if they tell us this is 40, what's this one over here? 40. What do we know about these two? They're the same. Can we find them? So we would set up a little equation where 3x plus 2 equals 4x minus 9. And then just solve it. So what would we do to solve it? Minus 3x, right? So we've got 2 equals x minus 9. Add that 9. So x winds up being 11. And then we'd have to plug that back in to find the angle. So we would do like 3 times 11 plus 2. So that's 35. So what's this one? 35. Now, I haven't even looked at the questions yet. I don't know what they say. But if I know that this is 35 and this is 35, what do I know about this whole angle? It's 70, right? And then if this is 40 and this is 40, what do I know with this whole angle? It's 80. So if I wanted to find this whole angle, I could, right? I would do 70 plus 80. That's 150. So this whole angle would be 30. 180 minus 150 is 30. So what are these two pieces of angles? They're 15, right? Now, I haven't even looked at my questions yet. I don't know what they ask. I just wanted to find all the stuff I knew I could find. So if we go over here and it says angle ARU. Angle ARU. So here's A, right? A R U. That's this angle. What does that angle measure? 40. We already found it. 40 degrees. We're going to skip 11 and come back to it in a minute. Angle QPK. So QP, where's the P? Up here? P, K. So we're looking at this angle right here. 35. So we know it. Now let's look at 11. So 11 says AU. Now what is AU? Is that an angle? No, that is a segment length. This segment right here, right? Now, here's what we know about incenters. Incenters are the same distance from the sides. So this segment is the same as this segment is the same as this segment, right? Here's the only problem. They didn't tell us any of those. We have zero information about any of those segments. Now, here's what I feel happened. Y'all see that little 20 degree right there? I feel like that's not supposed to be an angle measure. I feel like when they did this, that was supposed to be the length of AK, not degree, just 20. That's just supposed to be 20. And that's supposed to be how long AK was. And so if AK was 20, then AU would also be 20. And AT would also be 20. But where it is now, we can't find AU because we don't know anything about any segment in this. We got nothing. Do y'all see what I'm saying? Now, I think if I go back and check my answer key for this paper, it's going to say 20. But regardless, you could, like, that's just guessing. That's just being like, I think this screwed up. I'm going to go with this. Okay? Okay, the application, was it hard? What do you have to pay attention to? Which one it is, right? Is it an angle bisector? Is it a perpendicular bisector? Okay, I am done. Y'all got 6 extra minutes.